In this video, I'm going to show you how to construct a confidence interval for a population proportion. This procedure has a lot more assumptions, and so let's go through them. The first assumption is that you have to have a simple random sample. The second assumption is that the population needs to be at least 20 times as large as the sample. Now, here we might take a little bit of liberty based off of knowledge we're bringing into the question, but we'll talk about that a little bit more when we get to the example. The items in the population have to be divided into two categories. So this procedure is for items are in category one or they're not. You right? It's very much like a binomial situation. Either it's here or it's not here. And so we will identify the characteristic that we care about, and that will be what we focus on when we look at our proportion. And then our sample size really needs to be at least 20 items because we need at least 10 individuals in each category. The procedure for computing it will be approximately the same as any procedure for computing a confidence interval for one population. We're going to compute the point estimate, which is going to be the population sample proportion. We're going to find the critical value, and it is a z critical value. So that means we're going to use the standard normal distribution. Then we will compute the standard error, which has the formula you see. And then we will multiply the critical value by the standard error, and that will create the margin of error. And now, given the margin of error, we will add or subtract that to the point estimate, and that will get us our confidence interval. For the problems that I'm doing, I'm going to round the confidence interval proportion to 3 decimal places. You might need to follow instructions that you get specifically from your teacher or from other questions, but generally we will do the 3 decimal round off rule. All right, let's look at the example. Political polling. A simple random sample of 300 voters was polled several months before a presidential election. One of the questions asked was, are you satisfied with the choice of candidates for president? A total of 123 of them said they were not satisfied. We're going to construct a 99% confidence interval for the proportion of voters who are not satisfied with the choice of candidates. And then we'll have a second question that we will analyze. The first thing I'm going to do is I'm going to pull out the information from the, I have my sample size n equal to 300. And these are the voters. I have the individuals who are in my specified category, and my specified category is the voters who are not satisfied. So that, and the notation I'm going to use is X. And that's 123. All right, and so now what I want to compute is my sample proportion, and that's P hat. P hat is equal to X divided by N, and that's 123 divided by 300. I'm going to keep it exact by keeping it as this fraction. Follow the instructions stated, either keeping it exact, or if you're in a class with me, then we are also allowing you to round this to 3 decimal places, but definitely encourage you to work on keeping it exact. All right, now let's go and address the assumptions. So the first assumption is, do we have a simple random sample? And we're going to say yes, because it says we have a simple random sample. So yes, stated explicitly. The second assumption is that the population is at least 20 times as large as the sample. Our sample is 300 voters. 300 times 20 is 6,000. And there are definitely more than 6,000 voters in the United States. So, I mean, that's what I mean when I say we'll have to take liberties of knowledge that we know and bring to the question. So now our third assumption is the items in the population are divided into 2 categories. So yes, we have 2 categories. The categories are satisfied and not satisfied. So we meet that requirement. And then our fourth assumption is that the sample must have 10 individuals in each category. And so if we look at the values, we have 123 in this category, and then the difference, which would be 277 in this category. Therefore, these are both more than 10 in each category. So we meet that requirement. Given that all the assumptions are met, we can go on and continue with the procedure. Now, in the procedure, we're going to need the point estimate. The point estimate for us is the sample the sample proportion, which is 123 divided by 300. And then now I need the critical values. Now, the critical values are going to come from our confidence level. Our confidence level was 99%. You see it right here. So confidence level of 99% means that alpha is equal to 0.01. And then we're going to look at the normal distribution. So I'm going to do this with technology. In Desmos, I'm going to type in normal dist for the normal distribution. You need to put the parentheses in here, plus sign, so center. And we're going to look for the outer regions, the bounds that give us an area of 0.01 and the tails. This is our critical value, and 6. And now we're going to find the standard error and the margin of error. So the standard error is the formula square root of p hat parentheses 1 minus p hat close parentheses divided by n. And then the margin of error is going to be the critical value times the standard error. So depending on if you need one or the other, you definitely need the margin of error, but you might need to show the standard error. So that's what I want you to see, both of them. All right, I'm going to go and just compute that with the calculator. P hat is 123 divided by 300. And so I'm going to write it like that, parentheses 1 minus 123 divided by 300. You could also right there put in 277 divided by 300 and go ahead and do the subtraction if you desired, but you do not have to. Oh, and that's right, the sample size is 300. We knew that. All right, there's our standard error. And now I'm going to copy that. Nice little benefit of Desmos. I'm going to paste it. And then I'm going to multiply it by 2.576 in the front. And these are those values, standard error and margin of error. Okay, perfect. And now what we're going to do is we're going to compute the confidence interval. So the confidence interval is p hat plus or minus the margin of error. And remember, we're going to round to 3. So now I'm going to do a little bit of rounding. I'm going to call this, and then I'm going to use that. So 123 divided by 300. Here we go, plus m. And then 123 divided by 300 minus m. And those are upper and lower bounds of the confidence interval. All right, so let me go ahead and get 123 divided by 300 as a decimal. It's 0.41. So here's a couple of ways we can write this answer. We can write this answer as 0.410 plus or minus the margin of error, which is 0.073. We can write it in interval notation, which is 37, 0.483. And then I can write it in inequality notation, which looks like 0.337 less than the population proportion, which is P, less than 0.483. And these are your answers. All right, now let's look at part B and see what it is asking. Among the 300 voters were 158 women. These constitute a simple random sample of women voters. If this sample were used to construct a 99% confidence interval for the proportion of women voters who are satisfied with the choice of candidates for president, it is likely the margin of error would be larger, smaller, or about the same as the one in part A. So, what we're getting at with this particular question is how sample size affects the confidence interval. About half of the voters were women. And so, if we were to assume kind of the same proportion behavior of 41%, let's just say, times 158 will be about 65. So the proportion of women voters, and this time they said who are satisfied. So I actually need to go the opposite way, 158. Let's do approximately 158 minus 65. So 93, maybe 94, depending on, let's round down. Let's go round down. So 94. The calculations for this would change and they would use 94 instead. And so if you look, let's just adjust all these numbers to be 94, 94, 94. Oops, typos. And then we'll adjust the point estimate. Okay. Um, let's compare this margin of error to, let's compare this confidence interval to what we have. So the confidence interval for these values is going from approximately 24 to 0 point. So this is for part B. We know we'd estimate the new confidence interval as 0.244 and 0.382. And as you can see, there's a little bit of overlap on the end, but it's smaller, right? And so the question says, how is it likely that the margin of error would be larger, smaller, or about the same? The margin of error here is smaller because it's impacting the values that you see here in the calculation. These are smaller values. 94 over 300 is smaller than 123. And so everything's just a little bit smaller. The margin of error is about 0.69. And previously, the margin of error was about 0.73. So if you have smaller x, i.e. a smaller number in your category, you can expect the margin of error to be smaller, all else things being the same. Right. I hope that helps you compute the population mean, confidence interval population mean, and let me know if you have any questions in the chat.